Hey, welcome everybody. This is Madhu here from AWS in India. Welcome to all of you. Good afternoon, good evening, whichever part of the world you're connecting from. This is the AWS Third Shift program, which is something that we launched early part of the year to help developers, engineers, architects like yourself, uh, you know, get started on, use our technology in a more efficient manner, something that's more relatable to you. Look at how to use technology, take advantage of the services that we offer in a more efficient manner. So today we have Julian Simon, who's a global technical evangelist for machine learning at Amazon Web Services. He has been a CTO for over a decade in Europe, and then subsequently now he's been writing some phenomenal blogs enabling developers, data scientists across the world in building cool machine learning solutions out there. Um, Julian has been here to India before a couple of times, and he's spent some fantastic time, I think, Julian. So, and then,
Yeah.
here we happy to have him back here again and bring him to you. And over to you, Julian. Thanks a lot for coming in and doing this for us.
First of all, thank you very much for giving me the opportunity to talk to you today. Thank you, Madhu, for the kind introduction. Indeed, I really wish I could be in India again. I had a fantastic time, and I certainly want to come back as soon as possible. Right when it's reasonable and safe. And I hope you're all doing okay in those crazy times. I am based in outside of Paris. So today I want to talk about AI and machine learning, of course, which is my main topic. And I want to try to give you some real life advice, some pragmatic advice on getting started, and share with you some customer examples and hopefully show you that it's reasonably easy to get started on AWS. Okay, so here we go. And all questions are welcome. My colleagues will send me questions during the session, so please ask your questions, and I may answer some of them as we go or at the end of the session. Okay, I will definitely have some time at the end of the talk for questions and answers. Okay, so let's get started. So one thing I'm not going to cover is this. A lot of people still ask me, "Oh, is AI a real thing? Does it have a future?" And well, you know as much as I do. So my opinion is yes. It has a future for startups and enterprise and all organizations out there. Um, Beyond that, predictions are predictions. So if you want predictions, you can get there from whoever. And I don't have a crystal ball. I don't know about the future. What I think is more interesting is whether we, the IT community, the people who build applications and services and products, do we have a clear idea how to get from now to successful ML projects? And I don't think that question is very easy to answer. And I'm actually pretty skeptical when people come up with ready-made answers to buy this, use that, do this. It never really works, right? So to convince ourselves that we need a different approach, let's throw this to the bin. I'm a strong believer in learning from the past, and I think the IT industry in general is pretty bad at doing this. A lot of different industries, doctors, cooks, people who build actual buildings, people who build real things, they learn from the past. They learn from mistakes, and I think the IT industry doesn't. So, well, this quote from Einstein says it all. So let's just start by looking how we do collectively, and of course myself included, at adopting new technologies. Okay, and well, I've been around for a little while now, so I guess the only benefit is in growing older is experience. So let me share some of my own experience. So a while ago in 2000, the big story was web services, right? Web applications, even before we talked about web services. How did that go? I mean, generally, we all did a terrible job at this. We massively underestimated the complexity. We massively underestimated the infrastructure and operational workloads of running high-scale websites. And generally, we failed a lot before we succeeded. And a few years later, well, guess what? E-commerce was all the rage, and everybody wanted an online shop. And well, again, we completely underestimated the complexity there, and we just went for it. And guess what? A lot of those projects failed. And a few more years later, mobile commerce became the thing. We convinced ourselves that everybody would buy from their smartphone. And well, e-commerce and m-commerce are not exactly the same thing. And again, I saw, and I'm sure you saw, lots of projects failing again and again and again. And you would think, well, after failing for so many years, we would know better, okay? Well, no, because a few more years later, big data became a trend. And everybody thought they could easily build and scale very complex data warehouses and Hadoop clusters. And maybe they didn't even need them in the first place, but they wanted to build them anyway. And I think this one was the biggest failure of all. I mean, I've seen so many projects fail here. People buying, tons of infrastructure, servers, storage, etc., and literally, throwing everything away, throwing months or years of work and tons of money away because they had no clue how to do it. So, well, I guess the first conclusion that we could take here is Jaws is really not a movie about sharks, right? I think Jaws is actually a crash course in managing IT projects. And the terrifying truth about tech projects is very similar about the terrifying truth on the Jaws movie, right? Remember that? I'm sure you've all seen that movie. If not, it's a must see, right? So go and find it. So delusional stakeholders, people who are in charge, and they want things to happen, but they don't understand the ins and outs of the problem. So they just want it done, right? Just like in the movie, remember the movie, the mayor of that city, of that little town, wanted the beaches to stay open, even though there was clearly a shark, right? He didn't care. It's like business must go on. There is business pressure. We need to keep going, and we disregard the issues. Unprepared teams, especially when you deal with new technology, it is a little bit different from what you've been doing before. So you need time to learn, you need time to adjust your processes, and possibly you need new tools because it's a different thing, right? You don't go fishing in the river with the same equipment as you would need to catch a big shark, right? It's the same for IT projects. Improvised tactics, again, hunting a big shark or building a big data cluster is something that needs a plan. You can't just go and go for it. Well, the big data cluster is not going to kill you, but it's going to make your life miserable. So you need to think about that. And of course, we still pull through, sometimes because of random acts of bravery. And people will work extremely late, they will work weekends, and they will get something done, but they will be exhausted, they'll be frustrated, they might just leave the company, and in any case, it's not a professional and an efficient way to get things done. So I'm really impressed how we keep doing this again and again and again. And when it's about AI and machine learning, I'm wondering how things will go. So if I'm listening to a lot of people out there, they say, well, it's different, and it's the AI revolution, blah 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 blah. And you know what? Here's my opinion on this. Okay, so this is what is probably happening right now, and this is what will keep happening in the next years, because it's not different. If we keep doing the same thing all over and all over again, we'll get the same results, right? And there's this great quote, and there's a debate on whether Mark Twain or Albert Einstein said it first, but they're both very smart people, so that's okay. It doesn't matter who said that first. But if we keep doing the same thing, delusional stakeholders and bad tooling, et cetera, the same results will happen. And people will conclude that AI and ML is just, it's no good. It's a waste of time. It doesn't work. It's a buzzword, blah, blah, blah. And I think it's not, okay? So in order to avoid being shark food all over again, we need to move from those problems to those solutions, okay? And we're going to look at each one of them. So we need to manage stakeholders, and it is not an easy thing. It's not an easy thing to manage your CEO or your CFO, even your direct manager. So you have to set expectations on what the project can achieve, okay? And one good way to do this is to define clear metrics, okay? Because, saying, an opinion without data is not worth much, okay? So avoid opinions, stick to data, and in order to have data, you need metrics. What is it that your project is trying to improve? Then, of course, you need to be very honest about your skills. How much do you know about AI and machine learning? Is it reasonable to go and try to build this, or should you use existing solutions? In any case, you must pick the best tool for the job, okay? Again, are you trying to catch small fish, or are you trying to go and hunt sharks? Very different problem. There are lots of best practices out there, and it's not because it's AI ML that we should forget about them. And of course, as always, you need to iterate, okay? And if you successfully, and over time, I'm not saying you can just, snap your fingers and solve everything. But if you move from the problems on the left to the solutions on the right, your project has a better chance of surviving. And this is probably true for all IT projects, but let's look at what it means for machine learning projects. Setting expectations. So this is probably the single most important thing. And I keep saying this to customers again and again and again. What is the business problem you're trying to solve? And you would think, yeah, of course. Who in their right mind goes into a machine learning project without this? Well, I'm going to be cheeky here. I'm going to say most of you, my friends, are doing this, okay? Because machine learning is exciting and we want to get started as quickly as possible. And, we want to just have a taste of that. And sometimes, and most of the times, we don't have a clear objective. So find something that needs to be improved in your company. It could be, it must be quantifiable. It could be a business metric. It could be, replacing a manual process with an automated process, something that is clearly defined and something that you can write in one sentence on the whiteboard. If you need 10 pages to explain it, it's too complicated. So it needs to be simple. The second thing is, do you have data already that can help with the problem, right? What kind of data would a human look at? What kind of data would a human look at to solve this problem? Okay, manually. And do you have that data already in a backend somewhere in a database? Doesn't matter where it is. Do you have enough of it? If you have just 20 data samples, well, probably that's not enough for machine learning, and you need something else. So that's a good question to ask very early on, because it has an impact on what kind of solutions you can select. The next important thing is make sure you have a common understanding. Typically, machine learning projects have an impact on the whole company. It's very tempting to say, oh, it's just a data science problem. We're going to build it and we're going to deliver it, and it's a black box and we know it works, so it's fine for everyone else. This is not the way to do it. I'm sorry. You need early on to make sure, business people, IT people, people who will deploy and manage the solution in production are on board. And of course, the people who know the data best, so DBAs, data engineers, whoever understands clearly and precisely what the data looks like. You need all those people around the table to try and shape the project. Okay, if you hear that kind of stuff, so these sentences here need to ring the alarm, right? I mean, they will trigger the alarm in your brain. If you hear the boss, whoever the boss is, saying, oh, we want to see what the technology can do for us. Okay, you need to be very careful, because this is not good enough. It's not quantifiable. It's not a business objective. Someone will say, oh, we have tons of relational data. We can do something about it. Yeah. Okay, go and think very hard about the problems you want to solve. And of course, my favorite, someone read a blog post about a service. And honestly, maybe it's one of my blog posts, and they say, oh, I read this really cool thing and we should try it. Well, before you decide to try it, find something to apply it to. Okay, so those are a terrible way to initiate a machine learning project, and it's quite guaranteed you're going to fail. So if that's where you are right now, just fight for a clear definition of the project. All these are bound to fail, unfortunately. The second important thing is to define metrics. So what's the business metric that shows success, right? What's the baseline? What are you comparing to? Are you comparing to a human workflow that you want to replace? Are you comparing to an existing IT workflow, maybe not based on machine learning, that you're trying to improve? You need to know where to start from, right? Next, you need to think about what would be a significant and reasonable improvement. It's very tempting to say, oh, we're going to divide by a factor of 10 the number of misclassified support tickets, right, with a machine learning model. Sure, it would be great. Do you think you can get 10x improvement in the first iteration? How often did you get 10x improvement on the first try of your IT project in the last 25 years? Probably never. Okay, so why would you expect machine learning to be different here? So something reasonable, right? Maybe 10%, maybe 20%, right? Start small and think about how often you would want to improve. I think it's a much better option to say, we'd like to try and improve 5% every quarter, versus saying we want to divide by 10 next week or even next quarter. Because like I said, machine learning is an iterative process. So you need to think long-term. You need to think about what you can achieve in the first steps, and then what you can keep achieving again and again, and when to stop, right? At some point, there is no business sense in continuing to invest for diminishing returns. So you need to plan for that, or at least have an idea, general idea where you want to go. And of course, you need to make it clear what you're building. Okay, so a data scientist is going to tell you, the confusion matrix for our support ticket classifier has significantly improved. Okay, so if you're a data scientist and you have a meeting with your customers or your marketing stakeholders, or customer relationship stakeholders, go and try that one. See if they understand what you say. Or you could say, well, P90 time to resolution is now under 24 hours. This is really great. Okay, is that a business metric? Probably not. And people still don't understand what you say. Okay, so this one is slightly better. Misclassified emails have gone down 5.3% using the latest model. Okay, so now you're starting to make sense. Okay, you're starting to say that things are actually improving from a business perspective. Okay, but if you can go all the way, basically go all the way and say something like, the latest survey shows that very happy customers are up 9.2%. Okay, now you're talking. That's a good metric. Okay, you could say your business metric is improving the percentage of happy or very happy customers by 10% every quarter. Okay, that's a very clear objective, and you can easily measure it. And maybe that means you need to work on the confusion matrix. Sure, but no one cares, right? Only the data scientist cares. So fair enough, but you need to speak the language of people who are getting this into the hands of customers, right? All right, so now you know where you want to go, and you have a reasonable idea what the metric is. Now you have to think about how you can build. So building a data set, so you need to assess your needs and your skills. And I'll be very clear, you need to assess needs, not wants, okay? I want to work on the craziest AI and ML technology, right? Is it what the project needs? Probably not, certainly not, okay? So do what's best for your organization and your own customers, right? Not, if you want to work on something fun, right? That's what home projects are for, or open source projects. So you need to be very, very critical on what you really need. So, and what you can achieve in this company. So can you build a data set describing the problem? Can you clean it? Can you curate it? Is it something you have the skills and the manpower for that? Do you know how to write and tweak ML algorithms? And do you need that? Does that project require novel algos? Probably not, even though it's very, very fun to write. Do you know and do you need to manage how to manage ML infrastructure? Maybe, maybe not. Maybe you know how to do it. Maybe it doesn't make sense for that project because, cost is extremely important and you won't be able to justify full-time sysadmins for this, etc., etc. Okay, again, look at the two dimensions. What do you need to solve the problem, and can you do it, right? Is it justified to do it? And so based on this, you can evaluate the solutions that are out there, going from fully managed everything, fully managed infrastructure and fully managed services for AI and so on. And maybe that's fine. Maybe that's all you need, right? Or is your problem that specific that you need to go and build stuff yourself, right? So maybe you can use off-the-shelf components, but you need on-premise infrastructure because you're working for a company that requires on-premise deployment. So, okay, maybe there's the middle ground. Maybe you need on-premise infrastructure and custom models because it is a very specific problem, okay? So you have to look at all those dimensions and be very critical. What's the fastest path to success based on what the project needs, what your skills are, what your budget is, how much time you have to build a project, etc. And again, I'm sorry, it doesn't matter what you want to do, right? You have to build what's best for your customer. Okay, if you want to play with crazy GANs or something, or reinforcement learning, okay, well, go and write a blog post about it. Your project probably doesn't need it. So pick the best tool for the job, okay? And this is a long-lasting theory. You may remember the iron triangle of project management, okay? Well, there's an iron triangle of ML. You can pick cost, time to market, accuracy, but you can only pick two, okay? You cannot have all three, sorry. Not in this life. And again, the least expensive and fastest option is probably not going to be the most accurate. Okay, so if time is the most critical factor, if you need to show a proof of concept, if you need to show an early version very, very quickly, then probably there is no time to go and build a data set and select algos and train everything, blah, 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 blah. Okay, so you need to rely on maybe existing solutions. Okay, maybe it's enough to get started and get some feedback from your customers and show you're making progress and show some improvement. Maybe accuracy is only 75%, but if you're replacing something that was much worse, then fine, it's already a good start. And you can get started, collect feedback, and keep learning about the problem and keep improving. Okay. And of course, the diminishing returns are enforced here. It's quite easy to get to 80% accuracy. It's more difficult to get to 90. It's insanely difficult to get to 95, and everything beyond that is just even more difficult. So you have to know where to stop. What's the level of accuracy that's really, really good enough for the business problem, and how much would it cost to try and squeeze a little bit more? And probably it doesn't make sense. You're not going to invest a month of R&D just to get 0.1% extra, unless you can clearly tie this to a business metric that says, well, you know what, every time we improve accuracy by 0.01%, we make $1 million. Okay, now you're talking. So yes, let's go and chase that 0.01%. All right. There are some advances, of course. State of the art evolves all the time, so keep an eye on that. But I would advise you to keep an eye on actionable state of the art. And what I mean by actionable is stuff that you could use in your company with minimal effort. So pre-trained models, stuff that's available you can get from GitHub and use and experiment with, that's okay. A crazy research paper where no code has been shared and no data set has been shared is probably way too advanced and way too risky for you to look at. Okay, so transfer learning, pre-trained models, AutoML, all these are techniques that are moving fast, and they're probably worth looking at. So you have tools, you know where to get started, what your metric is. All right, so if you're doing all of this, you're in very good shape. Now you need to keep the project on the road. And, I will carry this to the grave. Things are not different this time. They're never different. They will never be different. Okay. When it comes to IT, well, it's the same problems again and again and again. So AI and ML is software engineering. Don't let anyone tell you otherwise, unless you're a researcher and you work only for to write research papers and advance the state of the art, and you don't have to go and productize that stuff, and you don't have to go and live with it for years and customers. Okay, if you're in that world, then fine, ignore what I say. But if you're listening to me today, I'm guessing you're trying to build businesses and improve businesses with AI and ML. So it is software engineering. So everything you know about it and everything you're hopefully doing, development workflows, test workflows, CI/CD, QA, documentation, versioning, etc., etc. All this stuff needs to be in place, right? If you're not doing it right, if you're not doing it like that, well, okay, you're experimenting and fine, but how do you take that model, how do you take that code, and how do you move it in production to serve customers, right? So all that stuff needs to be aligned, and all teams need to know what's going on. It's not okay if the data science team is working for 6 months in their dungeon, and then they build a model that they say work, and they throw it over the fence to the software team, saying, okay, well, let's go and put this in your app, it's working. And then the software guys package it in an app, and then they throw it to the ops guys saying, well, okay, just deploy this. It's not going to work. Okay, so the left hand needs to know what the right hand is doing. Okay, so all teams should be involved and know how to deploy, monitor, debug what's being built here. And of course, sandbox testing is great. It's important. You need to have that. But the truth is in production. So you need to get your model in production as fast as possible and as often as needed, because only when you put real life traffic, real life data on the model, will you know whether this is working or not. Okay. In the sandbox, it always works nicely because you have a curated test set, and it's nice and clean, and it's static, and whatever's wrong with it has been long fixed, hopefully. So it's always very good. Now, when you get the crazy data that your customers send, things are quite different. And the model that was so nice, the A/B test that was so nice in the sandbox, all of a sudden looks very bad. Okay, so you don't want to wait for 6 months to find out about this. So this means you need automation, you need CI/CD, you need an easy way to package the models, deploy them, retrain them, etc. So in a way, you need DevOps for ML. Okay, again, ML is software engineering, so you need to use everything that's working for other domains like web apps or databases, whatever. You can apply that to machine learning as well. Okay, and again, involve all the teams, right? So yeah, that's not a good practice, right? Let's shoot some barrels into the shark, and that will tell us where it is, and yeah, where we know how that went. Yeah, so you need to do better than that. And the last thing is iterate. Okay, you need to start small. Start with a simple problem, a small data set. Don't try and solve the crazy thing first, because especially if it's your first machine learning project in this organization, people do not know how to build those things. So you need to give some time to people to learn, adapt their processes, etc. So start with reasonable projects. Don't go for the moonshot project right away. You don't have resources for that. And of course, try the simple things first. So simple algos work incredibly well. Most of the problems out there are solved with linear regression, simple classifiers, XGBoost, etc. So before you go and try complex neural networks or state-of-the-art models, try the simple things. Maybe it's not good enough, but at least it will give you a baseline, right? So if a simple linear model gives you 78% accuracy, well, okay, at least you have that, and you can benchmark the more advanced stuff against that baseline. Okay, so always try the simple algos first, and try to go to prod quickly. Okay, because again, this is the only place where you will see how the model behaves with real data. And when I say prod, I don't mean, it could be actual production, or it could be, 1% of traffic, something small, but try to play unmodified real life data on that model, not the curated data set. Okay, so it could be a pre-prod environment or something, right? If you don't want to break production. But at some point, very quickly, you need to throw real life data on this. And of course, you need to look at prediction errors, understand what's going wrong, right? Why is this picture misclassified? Why is this customer classified as a premium customer when that person is clearly not a premium customer? Observe prediction errors. Talk to business experts, business domain experts. Ask them if with this data, they would have made the same mistake or not, right? You need to learn from the experts as well and adapt your model, maybe add more features, maybe do different data transformations. You need to understand what's going on, okay? So do you fix the data set? Do you need more data? Do you tweak the algo? Do you try another algo? You need to improve. And you repeat that process until accuracy gains become irrelevant to the business problem. Right? Like I said, very, very few problems require 99.9% accuracy, assuming it's possible to get there. Okay, so you have to know when to stop and move on to the next project. Okay, so it sounds simple, but if you keep doing this again and again and again, you will make quick progress, and you will build confidence that the project is going to be successful. And this works because machine learning is an iterative process. Again, I'll fight to the end. Some people will say, no, we need to do 6 months of research in the dungeon, and we'll tell you if it's a machine learning problem or not. Fair enough. Some problems are like that, okay? Crazy complicated problems. That's probably 0.1% of the problems out there. But when we look at industry problems, most of them are not like that. And we can go and iterate. And well, this is the iteration process that we encourage our customers to follow. And this is kind of built in some of our machine learning tools. So starting from the business problem, framing the problem, understanding what the problem really means. Can we use data to solve it? If so, then move on to collecting data, integrating it in a central place. If you want to call this a data lake, that's fine with me. If it's just a big folder with all your files, that's fine too, as long as you put everything in the same place. And then you can run ETL scripts to prepare clean data, etc. And then you can start usually visualizing it, analyzing it, understanding what that data looks like, what algos would maybe work with this. And then you move into the proper machine learning part, feature engineering, training, tuning, evaluating, etc. Right? And this is probably the part where you will iterate a lot, okay, until you meet the business goals. And then you go and deploy models, and you have to live with those models in production until you need to retrain them, okay? So, well, this is very iterative to me, right? So the more we run through that loop, the faster we run through that loop, the better our chances are that we'll build something that works. Okay. And well, does this work? So that's the question everybody has, right? Well, if we look at customers on AWS, I think this works because this is what those guys are doing, all of them. We have tens of thousands of customers who run machine learning and AI in one form or another on AWS. And people often ask, what's the typical customer running machine learning on AWS? And I'm sorry, this is one question I cannot answer. All of them, right? All sizes, all countries, all verticals, all of you in your amazing diversity, okay? Startups, enterprise, and public sector, etc., etc. So lots of different companies here. Okay. All right. So literally everybody, and some of them use high-level services, and we'll talk about that in a second. Some of them use machine learning services. Some of them build everything themselves and manage their own infrastructure on AWS. And that's fine, right? But the core principles stay the same, and I've summed them up in those 6 points. So I'm not going to cover all of those services today. I would take it would be boring, first of all, and it would take me 3 hours. So what you should just see here is, so this is the AI and ML stack on AWS. It's a big family. I remember when I joined AWS 5 years ago, you could fit all the AWS services in one slide, all of them. I think we had about 50 services. Now it's getting difficult to fit the AI and ML services on one slide. So I'm worried it's gonna be difficult to show this on one slide. It's very dense. So we have 3 layers. Okay, so let's start maybe at the bottom. So at the bottom, we have what we call the frameworks and infrastructure layer. And this one is for customers who want to manage everything themselves. Okay, they want to manage their own infrastructure. So it could be EC2 instances, or it could be Docker clusters, ECS, EKS, Fargate, etc. Okay, they know how to do this, and they think for their business, it's the best option to go and manage that. So fine, and they know enough about ML that they can use the libraries, the popular libraries directly. So maybe they build TensorFlow solutions or PyTorch solutions or something else. Okay, so basically they use compute storage services to build from the ground up on AWS. Okay, and for some users, it makes sense, and they can do that. In the middle, we have ML services, and this is the big family of SageMaker services. So SageMaker is our flagship machine learning service. It was launched at the end of 2017. And over time, it's grown quite a lot. And it's really become a collection of capabilities that let you focus on your machine learning problem without ever managing any infrastructure. Okay, so that's the big thing here. In a sense, you get the best of both worlds. You have the flexibility to bring your own code. So of course you can run TensorFlow, of course you can run Keras, etc. You can also use built-in algorithms if you don't want to write machine learning code, if you don't need to. And you can use very advanced capabilities like SageMaker Debugger and SageMaker Autopilot for AutoML, etc., etc. But you never manage a single server. All of this, whether it's training or prediction, takes place on managed infrastructure. So you just say, hey, give me 3 P3 2XL instances, which are GPU instances, and SageMaker will create them automatically, provision them, train your model, and stop them once training is complete. And you only pay, of course, for what you used per second. And if you want to deploy, you could say, hey, I want to deploy on an M5 endpoint. And so again, SageMaker will take a model, create an M5 instance, deploy an HTTPS endpoint to that, load the model, and you can start serving predictions from your endpoint very quickly. Okay, so zero infrastructure work, absolutely zero, and full flexibility with your code. Okay. And at the top layer, we have what we call AI services. So these are for, I would say, 2 types of users. So the first type is people who know nothing about machine learning, and they're not particularly interested, right? If you're a mobile developer, or if you're a front-end developer, you want to build a great user experience, okay? And maybe your application needs text-to-speech or speech-to-text or translation or image recognition. So you just want to call an API and get the job done. The last thing that you want is to learn machine learning, build data sets, etc. You don't care. You just want to build your great app. So this is what you can do with the AI services. Most of them are API services. Most of them are real time. So again, call an API, get the job done. And this uses pre-trained models built by AWS that we keep optimizing all the time. Okay. The second category of customers for this is machine learning practitioners who do not want to deal with a certain aspect of the project. So let's say, for example, your project needs translation. Okay, maybe you have a natural language processing project, and you get documents in 20 different languages. So one option would be, maybe it's worth trying, maybe put everything in your native language. Okay, so translate everything to Hindi. Okay, and then work on that data set. So you could say, well, translation, is not the core problem here, and I can use maybe the Amazon Translate service to translate everything and then build my NLP application, right? Or maybe you need speech to text, which is very, very difficult to build in your app. Maybe you need to process audio documents again and do NLP analysis on that. So why not use Amazon Transcribe, which is our speech to text service, to transcribe and then run your own NLP code on the transcriptions. So these services are, they shouldn't just be seen as, oh, these are for newbies and people who don't know what they're doing. There is that. And there's also um, the acceleration angle, right? Shrink the problem to the core ML problem, and take care of everything else using high-level services. So we have different things. We have vision, speech, text. We have a search service that was launched very recently called Kendra that uses NLP techniques. We have a chatbot service. Personalize is personalization. Forecasting, forecast is forecasting time series. We have fraud detection. Code Guru is an automated code review service and code profiling service in production. And we have also Contact Lens, which is an ML extension for contact centers with sentiment analysis, automatic transcription, etc. So that's quite a big family. So instead of going through the full services, which again would be boring, maybe we can look at a couple of examples. And I'm not going to go through everything. I just want to give you some examples of what customers are building here. So a very popular use of all those services is customer service, okay? Because these are extremely workforce intensive, and if you want to scale those activities, well, you need to find better way than just having more and more people in the room. So problems like running analytics on the customer's voice in real time. Can you tell in real time if this customer is happy or not? If the call, if the service call is being handled in a proper way? Because if not, if you detect the customer is getting negative, then maybe you need to escalate the call to maybe a more experienced customer representative. Being able to do multi-language is very, very important. Maybe you have service centers that serve different countries, different languages. So you definitely need multi-language transcription to run analytics. You need translation, etc., etc. So here, by combining those services, so Poly is a speech to text, text to speech, transcribe, speech to text, translate, pretty obvious. Comprehend is natural language processing, so sentiment analysis, entity extraction, etc. Lex is chatbots. By combining them, we see customers building very, very clever stuff, right? And this helps them serve their customers better. This is an interesting one. Media workflows. Again, well, there's lots of data, right? lots of text, lots of video, lots of images, and here you can use services like recognition to automatically detect objects or detect people in images and videos. Again, you can use comprehend, transcribe, translate, textract, which is another service for to extract text from documents, text and structure. You can automate your workflows, and you can just manage your mountains of data much, much easier. So things like tagging media with metadata, finding people who are actually appearing in videos. There's a feature in recognition for celebrity detection. So you could index your video content or your image content and tag your files with whatever people you're looking for here. Content moderation, you can do that with Comprehend. There's sentiment analysis as well. You could build your own models with SageMaker if you wanted. Very recently, Transcribe added a vocabulary filtering feature, so it's available in real time and in batch mode. So if you want to do, I have a silly demo on YouTube, which I'm not going to show you, where I do a profanity filtering in real time. So it's offensive, but it's for the it's for the purpose of the demo, where I just go and say a lot of profanity and automatically in real time transcribe censors whatever I'm saying. And this is really, this is really important, right? You could use for other purposes, but for profanity filtering, it works very well. So just an example. Another very, very popular use case, of course, is localization. And we see companies who operate globally, like hotels.com. They have websites that serve customers around the world. And imagine translating millions of customer reviews and hotel pages in many different languages. It's not doable, and there's no economic value to doing this manually. So the only way you're going to do it is automating it. So you can use Translate to do that, and just automatically translate with a good level of quality all those long tail pages. And subtitling, yes, is an interesting example. You can extract the audio track from videos using Transcribe. You can translate it automatically with Translate. Again, you can combine those different services. Again, most of these are just one API call every time. So it's very, very easy to use and very easy to combine them. Yeah, I think recommendation is interesting as well. So Personalize, as the name implies, is a service that lets you build personalization and recommendation models. So this one is a little bit different, so let's say Translate is really an API service. Okay, you give it a piece of text and the language you want to translate into, and you get your answer. Okay, very simple. So Personalize is basically managed personalization. So the only thing you have to do, so Personalize is managed personalization. So the only thing you have to do is bring your CSV files into Amazon S3, and there's a simple format to enforce, of course, and you upload that to Personalize, defining the user ID column and the item column, and build on that user item interaction. Personalize can build models. So this is really, really popular for retail, Subway, Domino's, etc. Very easily build personalization models without going into the crazy machine learning stuff, right? Which is not always needed. Okay. Forecast is a similar idea. It's a managed service to forecast metrics, time series. So it could be business metrics or supply chain metrics, etc. And it's the same story. You bring your data to your CSV data to S3, upload it to Forecast, either select an algorithm or let Forecast automatically select one, and you build and train high quality forecast models. So that's pretty cool. All right. There are so many use cases, but I'm mindful of time. I just want to mention quickly one last thing. So if your first step before you even consider building your own machine learning project should be to go and check out the AWS Marketplace for machine learning. So I'm quite sure you're familiar with the AWS Marketplace for EC2, where you find thousands and thousands of packaged third-party solutions for security, databases, analytics. I mean, literally everything. And we've done the same for machine learning. So now we have hundreds of algorithms and models that are off the shelf in the marketplace, and you can just go and select them and deploy them on Amazon SageMaker in just a couple of clicks, and test them out. Okay, so these are pretty advanced models. Every time I take a look there, I find really, really advanced stuff. It's not toy models at all. These are built and optimized by AWS partners, and there's a lot of value in them. And actually, we ran a hackathon a few weeks ago to encourage developers to go and experiment with machine learning models. You can find the URL on the screen here. And we also recorded a webinar where we explain the hackathon and we go through the winning entries, etc. You might like that. And I just want to show you the winner. So the winner is a project from Canada called Mobility Explorer. And the idea is using camera feeds from, is it Calgary, I think? The author is using pre-trained models to detect and count cars, bikes, and pedestrians. And then he maps that information on a 3D map, okay, showing you what are the busy parts of town, what are the less busy parts of town. And this information is available every 5 minutes because the camera pictures are refreshed every 5 minutes. So it's almost real time, right? Almost real time. And the way this was built is this. So on the left-hand side, you can see 3 pre-trained models for human detection, bike detection, and vehicle detection have been deployed to SageMaker endpoints. So these are CVDR models. So just ready to go, right? Just deploy those 3 models. And then using Lambda functions that wake up every 5 minutes, grab cameras from grab pictures from the cameras, predict them, and then push the data to Postgres, and then build the graphs with more Lambda functions and build the visualization, etc. And this is all it took, right? So it's a great way to very quickly build ML solutions. So you should absolutely go and look at the marketplace and see that, you know, maybe there's a model that solves your problem, or it's good enough to get you started, and you can quickly go and experiment with it. All right, well, that's pretty much what I wanted to tell you. So hopefully that was useful. If you want to know more about all those services, you can go to ml.aws. That's a nice, simple URL, and you'll find everything there is to know about all the services that I discussed here, plus, of course, customer use cases and documentation and pricing. Everything you need is there. ml.aws. If you want to stay in touch, my Twitter account is JULSimon. And you can also see the URL for my blog and my YouTube channel, where I post my podcast and also some how-to and tutorial videos. Okay, so so that's a lot of content. So let me take a look at questions. Just all right, let me scroll through the questions. All right, so first question. How should we apply AI/ML in small projects? How do we identify the opportunity to do this? So the opportunity lies in either replacing manual processes, right? Or improving IT processes that are not based by machine learning. So stuff like classifying support tickets. I take this example a lot because as soon as you run any kind of website or any kind of retail operation or any kind of service operation, you need to handle customer support. And the main question here is, who's the best person in the company to answer this, right? So classifying tickets, understanding what those tickets are about is a good first step. Extracting, the keywords, etc., and then routing those tickets to the best person or the best team is also an interesting next step. Customer segmenting your customers, right? Maybe you have different types of customers for your company or your service. So looking at their data points, you can figure out if a customer is a premium customer or a non-premium customer, and this can actually help you detect a churn, right? Because if a premium customer starts to behave as a non-premium customer, then maybe that person is going to stop using your service at some point. So maybe it's important to engage with that person and understand why they don't use the service so much, or send them maybe a promo coupon or something, get them engaged again. The gaming industry, the video game industry is a master at that. You can see that all the time when we play games on the smartphone. Stop playing a game for a few days, and all of a sudden, you get you get notifications and promotions, and they're trying to get you to play the game again. So yeah, fraud detection is another good example. We have again a managed service similar to Personalize and Forecast. If you're doing online business, you need to figure out if transactions are fraudulent or not. So again, look at the data intensive problems in your organizations, and analyze how you're solving those features and those problems, right? Are you doing it manually? If so, is there a way to quickly build a first model to improve that? Okay, and it's not about replacing humans; it's about doing things faster and leaving humans to focus on maybe the 10% of tickets or problems that are too difficult for the machine learning to figure out, right? But if a ticket says, I can't log into my computer, it'll be easy for a machine learning model to understand what that is. So route that stuff, or maybe send automatically an automatic email to that person with the link to your knowledge base on how to log in, etc. That kind of stuff. Simple things. You don't need to go for the moonshots. Okay. That's a very good one. Thank you to whoever asked this. The other one was good too, but this one is important. To what extent should the data science team be technical? Where do we define the boundary between engineering teams and data science teams? So this is very, very important because, I like to make fun of data scientists every once in a while. And fair enough, right? Some of them, they do not want to get involved with anything IT or anything ops, and they don't want to get involved in the product too much, right? They want to build models, and depending on your organization, this could be a big problem, right? If you're in a startup, you can't afford to have people who don't care about the full end-to-end workflow. It's I think it's a little bit silly to do this, and it's not efficient. And it's not even efficient for them, because if I was a data scientist, I would not want to go through gatekeepers or ticket systems to get my code deployed in production. I would love to be fully autonomous, tweak my algo, train on infrastructure that I can create and deploy it on infrastructure that I can create, and maybe go all the way to production like this, okay? Instead of saying, oh, here's the model, go and deploy it, and then you have to wait for hours or days for something to happen. So I think if you can, and to answer that question, I think if you can encourage interaction and knowledge exchange between the data science team and the software engineering teams and the DevOps teams, it's best, right? Of course, everybody has their own specialty and their own taste, and that's fine, right? But if you understand the other guy's problems, then you can anticipate them, and everybody's going to be so much more efficient. And I believe very strongly in autonomy, right? People should be able to go to production in a controlled manner, of course, but they should be able to put stuff in production themselves, okay? Because the engineering guys, they have better things to do than just deploying your model. They need to worry about security and monitoring and quality of service and scaling, etc., etc. So you don't want to waste their time either. So that's a great question, and to me, it's a culture problem and it's a management problem. So you need to encourage teams to work together, right? Very early on. All right, so we have a more pointy question here. Which algorithms or services can I use for log anomaly detection? So there is an anomaly detection algorithm in SageMaker. Okay, it's a built-in algo. It's called random cut forests, and you can just use that directly. Okay, so you need to prepare the data set, of course, but you don't have to write machine learning code. So random cut forest in SageMaker. But then again, I would probably look at the AWS marketplace. I wouldn't be surprised if you found log models, log analysis models for maybe cyber security and so on. Okay, so yeah, you take a look at that. All right, another one. So which development tool is good for development with ML and AI? Well, it all comes down to favorite preference. So I would say, obviously, the most popular tool these days is Jupyter and Jupyter Notebooks. So this is what you find in SageMaker. You can create managed Jupyter Notebooks. And we have also a machine learning IDE called SageMaker Studio, which is based on the Jupyter Lab with our own extensions to integrate our other features like AutoML, etc., etc. So if you want a managed IDE, you should take a look at SageMaker Studio. But generally, SageMaker is really it's about SDKs, right? So and it's Python, so you can use that if you want to use it in PyCharm or VS Code or anything. It's fine. I'm personally in favor of letting developers select the tools that they like. And again, as all these services are APIs and SDKs, you can use anything that you like. All right, next question. What if we get stuck somewhere after trying hard to attain accuracy? What steps can be taken to improve further? That's a good one. Yeah, like I said, it's usually reasonably easy to get to, let's say, 80% accuracy on tabular data and even on deep learning problems. So you get there, and then, like I said, it gets the slope gets steeper and steeper all the time when you try to climb towards higher accuracy. So if you did I would say if you did the obvious, so if you tried hyperparameter optimization, which is available in SageMaker as well, you can always squeeze extra accuracy just by doing hyperparameter optimization. If you try different algos and if you kind of hit a plateau and you have no clue what to do next, okay, well, this is when you should talk to a data scientist, right? This is because at that point, somebody will have to crack the model open and see, what's going on. Why are you mispredicting certain samples, et cetera, et cetera. You need to go into deeper analysis of the problem. And this is where you do need data science skills. Okay, so data scientists are definitely useful for that. But I think if you can get to 80% by yourself and then go and find an expert, a consultant, or hire someone in your company, then you can say, okay, we did all of that stuff by ourselves. Now we need you to help us get to 90%. Well, that's very good, because you will only pay that person for proper expertise and not for I would say the basic work. Okay, so yeah, try all kinds of different algos. Try SageMaker, try the high-level services, see how far you can go, and then if you're really stumped, then okay, go and bring the expert, right? All right, another one. I think, let me see if I missed anything. There's a question on QuickSight ML Insights. So that's an interesting one. So QuickSight is our BI tool, and not so long ago we added machine learning capabilities, so the so-called insights, where you can forecast time series and do things like that. And so the question is, should I write my own forecast model, or does QuickSight or is QuickSight good enough? So my answer to this is always the same. Laziness is a virtue, because laziness saves time and money. So anytime you can work with a high level feature, do that. Okay. And it's really in your best interest. If you find that, and only you can tell, right? If you find that the forecasts that you get from ML Insights are clever enough and accurate enough, looking at actual data, comparing the forecast to real data later on, if you find those forecasts are good enough, then why would you go and build something else, right? Maybe you want to, maybe it's fun. So as a home project, why not? But as a business professional, you have to be mindful of your time. So if that works, why look for something else? Now, if you think it doesn't work, then I would get in touch with your AWS support representative if you have one, or I would definitely post a message on the AWS forums saying, "Hey, I'm seeing this, and it looks like these predictions are not really accurate. Is there a problem? Maybe your data is not the right format or something. See if you can help." But only go and build if you think you're going to do a better job, right? If until you know you can do a better job than this because you have the skills and you have the granularity of data and you have the clever algo, etc. Until you're reasonably confident you're going to do better, don't, right? Because machine learning is like security and cryptography, right? I mean, everybody think they can do it better, and then catastrophes happen. So and you're going to waste time, months, maybe more, and money on something that will not deliver. Okay, so and I would say the same for recognition and translate, and start with those services. If you have evidence-based data that tells you you have prediction problems, then tell AWS, okay? And if it is a fact that your data does not work well with that algo or that model, and you need to build something else, then fine. But you need to have evidence first, otherwise you're going to waste your time. All right, I think I missed one. Can I touch upon explainable AI? Yes, I can. So, and how can we achieve it on AWS? So, explainable AI is exactly what I said earlier. So, cracking the model open. So, actually, we have a capability called SageMaker Debugger. And so, the name implies that it's really about debugging, but it's really about inspecting models while they're trained. So, you can literally see model parameters, model metrics, etc. All the internal state of the model can be explored and analyzed and saved during training. Okay, so you can do that, and then you can explore the data and figure out, time step after time step, how the model is learning and what's going on in there. Or you can even while the model is being trained, you can use that data to change the model. And one example of that is we have a model pruning notebook in this. Look for SageMaker examples on GitHub. And there's a pruning example with PyTorch. Pruning is a technique where you shrink the model while it's being trained because some neural connections are useless. Okay, so by inspecting the weights of certain neural connections, we see that, okay, this connection doesn't help at all in prediction, so we can remove it. And we actually shrink the model by a factor of 3 at least, I think, without losing any accuracy. So understanding, and there's a BERT example as well. So BERT is a popular model for NLP. It's a huge one. And we also have a real-time example understanding how BERT predicts. So I'm not gonna lie, this is extremely advanced stuff. Okay, so it's not for everybody. You have to understand how those models work. But if you know how to do that, then SageMaker Debugger is the way to go. And you can see exactly what's going on, and you can explain the importance of features, etc., etc. So that's a pretty good one. All right, I think we're almost out of time. Somebody yell at me if I'm getting horribly late. Okay. Quick insight on how personalization works in Amazon. So let me call Jeff Bezos first. Okay. So no, seriously. So I'm not going to talk about anything we built internally, But one thing I can say is everything AWS builds comes from the experience of Amazon, especially when it comes to machine learning. Because you can imagine Amazon.com has been doing machine learning for over 20 years now. And so we learned a lot. We have pretty large scale. So when we build something like Amazon Personalize or Amazon Forecast or all these other services, we use the best practices that we learned from Amazon, right? So data preparation and algorithms. Some of the algos in there are actually have actually been invented by Amazon. So you, in a way, you get to run the same stuff that we run. Okay, except we just make it simpler to run because it's a high level service. So yeah, definitely you benefit from what Amazon has been doing over the years. Okay, well, I think I'm pretty much done, right? So unless my colleagues ask me to stay on for another 4 hours, I think we're going to call it a day, right? So I want to thank you very, very much for participating in this webinar. I hope you learned a few things. Again, you're happy to connect and happy to answer questions later on YouTube or wherever you find me. And I sincerely hope I can make it to India at some point. 2020 looks difficult, but maybe 2021. And I'm sure Madhu will remind me that I said this, and I'll be more than happy to come again. Right. So thank you very, very much, and have a great day.